Hello beautiful people and welcome. In today's video we are going through the IM1 Chapter 10 practice exam. Just a reminder that I will not be including any proofs in this exam. For my class I did provide a proofs packet. Please refer to that packet. Proofs will be on the test. They just won't be on this practice exam. Alright, let's go ahead and get started with question number 1. Given that line A and B are parallel, named the angle relationship between x and y. So if you take a look at x and y, you'll notice that they share a line. And when they share a line and we can connect them, so here's x and here's y, that means the angle relationship is a linear pair. Question number 2, it's asking for the angle relationship between, again, x and y. Since we have angles directly across from each other, these are vertical angles. Question number 2 is a multiple choice question. It says, what does it mean when angles are congruent? Circle the correct answer. Congruent are angles that are equal in measure. Answer is A. Congruent means equal in measure. Moving on. And I think these are a little bit out of order. Do I have a backside? Oh, I do have a backside. All right, so I'm going to turn on the backside. What does it mean when angles are supplementary? The trick here is when you want supper, you want a lot of food, okay? So that means that when we're talking about angles that are supplementary, we want the degree that's larger. So supper, supplementary, 180 degrees. Complementary, when people give you a compliment, they're correct, meaning compliment is something that is nice, polite. So when someone says, hey, I like your shirt, means that you have a nice shirt. And when you do that, when people are correct, they are right. That is a nice shirt. When you have something that's right, it is a 90 degree. Okay, just quick little things to help you remember. Supper, supplementary, 180. Complementary, a compliment, they are right, 90 degrees. Moving on to question number 5, name the angle relationship, then solve for x. So a little bit different than question number 1. We not only are naming the angle relationship, we are also solving. Now if you take a look here, we have an angle 16x plus 5 in this section and 18x minus 5 in this section. These are corresponding angles. Corresponding angles, what does that mean? That means angles that are in the same location. I was to pick this up, put this on top, they would overlap. And what does that mean? That means that these angles are congruent. And what does congruent mean? It means equal in measure. So 16x plus 5 is equal to 18x minus 5. And now our goal, our objective is to solve for x. I'm going to do a dotted line. I'm going to subtract 16x, both sides. 18 minus 16 is 2. Bring down the minus 5. I'm going to add 5 now to both sides. And last step, divide by 2. Running out of space, that's okay. So we get x is equal to 10 divided by 2, which is 5. Okay, next one. Again, name the angle relationship and solve for x. Here we notice we have our angles. I have an angle here and an angle here. Notice that both of these angles are inside of the parallel lines. So we know we have an interior. And are they on the same side of the transversal or on opposite sides? And we notice these are kind of like opposite sides. One's on top on this side, one's on the bottom on this side. So these are called alternate interior angles. Now remember, alternate can be abbreviated. Interior also can be abbreviated. Angles you got to write out. Alternate interior angles are angles that are on the inside, but on opposite sides of the transversal. One's on top, one's on the bottom as well. So that means that these angles are also congruent. What does congruent mean? It means they are equal in measure. And if they're equal, we set them equal to each other. Dotted line, minus 14 both sides. 14x, that is. Bring down the 13. Bring down the negative 3. And 16 minus 14 is also 2x. I'm going to add 3 to both sides. 2x is equal to 16. Divide by 2, divide by 2. X is equal to 8. Okay, moving on. C, again, name the angle relationship and solve for x. This time we have angles. We have one out here and one down here. Notice that these angles are not, here's my inside bubble, here's my inside of the parallel lines. Notice that neither of these angles are on the inside, so both of these angles are on the outside, so exterior. Now are they on the opposite side of the transversal or on opposite sides? These are opposites. This is called an alternate exterior angle. So alternate again, you can abbreviate exterior, you can abbreviate angle, you got to write out. Alternate exterior angles are angles that are congruent. What does congruent mean? It means they are equal in measure. So 17x is equal to 85 degrees. Divide by 17, divide by 17. 85 divided by 17 is 5. Next one, notice we have two angles that are both on the inside. So here's my inside bubble. And immediately I'm noticing that they, yes, are on the same side of the transversal. When they're on the same side of the transversal, that means they are same side inside angles. But we don't call them same side inside, we call them consecutive interior. If you want to abbreviate interior, INT, that's fine. Okay, what does it mean to be consecutive interior? It means they are on this inside, same side of the transversal. What does that mean? That means these angles are supplementary. What does that mean? It means that these angles add together to give you 180 degrees. So we have 9x minus 1 plus 109 degrees is equal to 180 degrees. They are supplementary. Versus here, these were congruent. Okay, dotted line, let's go ahead and combine like terms. So I'm going to remove the parentheses and I'm going to combine 109 with that negative 1. So 109 minus 1 is 108. Going to subtract 108, both sides. Bring down the 9 times x. I get 72. Dividing by 9, both sides. And I get x is equal to 8. Okay, next one. What do we have? Noticing I have an angle here, I have an angle here. These are angles that are directly across from each other. Their angle relationship is that they are vertical angles. And what does it mean when they are vertical? That means they are congruent. What does it mean to be congruent? It means angles that are equal in measure. So I'm going to say 125 is equal to 18x minus 1. Dotted line, I'm going to add 1 to both sides. We get 126 is equal to 18 times x. Divide by 18, divide by 18. And I get 7. Go ahead and flip over the paper. Next question is asking for you to answer the following questions to find the shortest distance from point A to y equals 4x minus 2. So this is how you're going to see these type of questions laid out on the exam. It's kind of like a guiding question, meaning I will guide you through this type of question. And as long as you follow these steps, you should be able to get full credit. Step number 1, graph the following line. So I'm going to find a -2 on the y-axis. So my -2 is down here. I'm going to put a point. Next, we have a point here. So this 0, -2 is the point that I'm pointing at right here. Next, we want to identify our slope. So I'm going to circle this 4. That means we have a positive slope. Positive slope means we're going to be going up 4. And because we don't have a denominator, we're always going to go right 1. If we do have a denominator, that means we're still going to the right, except we're going to go to the right, whatever that is. So I'm going to go up 4. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. And then once you're out of space, you want to go the opposite direction, but following that same pattern. You're going to pick up a ruler or a straight edge. It looks like I do not have a ruler. That's okay. So I'm going to pick up a straight edge. I'm just going to use a sheet of paper. I'm going to line up my paper a little bit underneath my point. So when I draw, hopefully this doesn't mess. I'm going to use pencil because I don't trust myself. Okay. There it goes. And we have our line. Next, step number 2, we want to graph the point -3, which is on our x, and 3 on our y. So -3 is here, 3 is here, so we have a point like this. Okay, next we want to identify the slope that is perpendicular. So I'm going to take a look at A, where I identified my original slope, and I'm going to make it opposite reciprocal. So opposite reciprocal is when you see a positive, you're going to make it a negative. Reciprocal is when you have a fraction and you flip the fraction. So now I have a 1/4. So that means my new slope is I'm going to go down 1 and to the right 4. And D is asking you what is the point of intersection. So we haven't found that yet. We're going to go back up to our graph. I'm going to put my marker here on this point, this orange point that we had. Then I'm going to use my perpendicular slope. So I'm going to go down 1 over 1, 2, 3, 4. And I'm going to find my point of intersection. I'm going to use again my paper here to help me with my graphing of a straight line. And when you do this, you want to always draw a right angle here, because when you are using a perpendicular slope to the one that's given, you are creating a 90-degree angle. Now, what is this point of intersection? So we have 2 points here. We have a given point, and we have that point of intersection. So orange was given, and then this green point here was your point of intersection. So point of intersection, we're going to go down here. This is x, so x is 1, and y was 1, 2. Now we're at E. Find the distance from the point 3, negative, comma, 3, and the point of intersection. And the point of intersection was 1, comma, 2. We're going to write out our distance formula. Distance is equal to the square root of, we have 2 parentheses, both of them are squared, and we got subtraction in the middle. We got x2 minus x1, y2 minus y1. So we need to go back to our 2 points and label them. I'm going to label them here. So we got x1, y1, x2, y2. So x2 is 1, x1 is negative 3. Be careful with the double negatives. y2 is 2, y1 is 3. So the analogy we use in class is if I am remodeling my kitchen, I do not bulldoze my house. So just because I'm going to be working on the inside of the square root doesn't mean the square root disappears. It actually stays. So before you even touch your calculator, please draw the square root symbol. Then I'm going to type in exactly what I see inside of the square root. Pressing enter, and I get 17. If you can, you have to simplify the radical, the square root. Because this is 17, this is a prime number, this cannot be simplified. This is your answer. Okay. All right, let's go ahead and move on. Same type of question for number 7. We want to find the shortest distance between point A and the given line. Step number 1, let's go ahead and graph the given line. So I'm going to take this 2, I'm going to find it on the y-axis, and then I'm going to use my slope to draw the line. So I'm going to kind of bring it over here. I see a negative. That means I'm going to be going down. 2, always to the right. 3. So down 2, 1, 2, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 1, 2, 3. And again, once you run out of space, you want to go the opposite direction. 1, 2, 1, 2, 3, following the pattern of the line. Okay. Using, again, either a straight edge or a sheet of paper or a ruler, I'm going to draw my line. Again, try to put your rulers a little bit under your points, so that way your marker is going to be on top of them. Arrows are required. It does go off to infinity. So that's step number 1. Step number 2, we're going to graph the point 7, 6. So find 7 on the x, find y, 6. So here's 7, here's y, 6. So we're going to have that intersection here. Next, we want to identify the slope that is perpendicular. So again, I'm going to go from A to C, and I'm going to do my opposite reciprocal. Opposite means if I see a negative, I'm going to have a positive now. And if I have 2/3, I'm going to have 3/2. So that means I'm now going up 3 and to the right 2. Now where's that happening? I'm going to put my marker on that orange dot. And now I'm actually going to switch to pencil because, you know, I am human. I can make mistakes. So now I'm going to go up 3, 1, 2, 3, to the right 2. Now when you do that, 1, 2, 3, 1, 2, notice that I'm going away from the line that I need to make contact with. So yes, these points are helpful because now I'm going to go the opposite direction. 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. And when I make that connection with the line, I am going to draw my segment, but be very careful. Do not go past your orange dot. So my connection is between the orange dot and the line. I am going to go back to draw my right angle. And I am going to be erasing, removing these extra points. You don't want anything extra here. Because we want the shortest distance, if you go past the point, it's, no pun intended, it's pointless. So let's go ahead and erase everything here. Now, D, what is this point of intersection? So again, we have our given point. And now we have this point of intersection here. And this point of intersection is on the x-axis, it is at 3. On the y-axis, it is at 0. So 3, 0 is our point of intersection. Next, it says find the distance from the given point, 7, 6, and the point of intersection, which we said was 3, 0. Let's label our points. x1, y1, x2, y2. They're asking for distance, so we are writing out the distance formula. x2 minus x1, y2 minus y1. And we're going to plug in our points. So x2 is 3, x1 is 7, y2 is 0, y1 is 6. Again, just because I remodel my kitchen doesn't mean I bulldoze my house. So that means that your house, your square root stays. Type in exactly what you see inside of the square root. And we get 52. Now remember, if you can simplify your square root, you have to simplify your square root. So this is where we're going to pick up our calculators and we're going to ask ourselves, what is the closest perfect square to 52? So if I do 8 times 8, that's 64, that's too big. So I'm going to drop it down to 7 times 7, which is 49. That does not work. 6 times 6, which is 36. That does not work. 5 times 5, which is 25. That does not work. 4 times 4, which is 16. That does not work. 3 times 3, which is 9. That does not work. 2 times 2, which is 4, and 4 does work. So again, just because I remodel my kitchen doesn't mean I bulldoze my house, so my radicals stay. It's still being multiplied. We got 4 and 13. Make sure that this number, this first number, is the first number you write. Okay, whatever you divide by, that goes first. Whatever your calculator gives you, that's second. Then we look at our cheat sheet, or we have this memorized. The square root of 4 is 2. So now we have 2 times the square root of 13 as our answer. Okay, moving on. Question number 8 is find the distance between 2 parallel lines. So a little bit different. It does have its similarities from the last 2 questions. Erase this. Okay, step number 1 is to graph both lines. So let's go ahead and do that. Notice for both of these, you do have a slope. I hesitated there for a second. A slope that is the same. So I am going to circle these, and I'm just going to say, okay, these are positive. And we have positive means we go up 2 and we go to the right 1 because we don't have a denominator. Let's start with the line on the left and find a 4 on the y-axis. We'll make this one orange. Then again, because the slope is the same, we're going to go up 2, 1, 2 to the right 1, 2 to the right 1, up 2 to the right 1, up 2 to the right 1, and again follow that same pattern. And then we'll connect it in just a few moments. Again, either find a straight edge, a ruler, or a sheet of paper. Line them up to the best of your abilities. Now I'm gonna have to press down. There it goes. And we have our first line. We're gonna do exactly the same thing for our second line. This time I'm finding a -1. And again, I'm going up 2 to the right 1, 2 to the right 1, etc. These lines should not touch and they should not cross. So if for some reason your lines do have an intersection, that means something went wrong. That means you graphed one of the lines incorrectly. Line them up and then go ahead and connect. And again, arrows are required. So step number 1, graph the 2 given lines. Identify the perpendicular slope. So it doesn't matter what original slope you're going to look at. You're going to take the opposite reciprocal. So that means if I had a positive, I'm going to now have a negative. And if I have a 2 over 1, now I have a 1 over 2. So my new slope is down 1 and to the right 2. Now this is where things get a little bit interesting in solving using perpendicular slopes, in that our point number 1 is going to be random. That does not mean you choose random numbers and you write them down. That means choose a color. So I'm going to choose, I don't know, I'll choose the blue one. I'll choose blue, and then you just kind of randomly pick a dot. So maybe it's like stop. So when I said stop, my marker landed on this point, and I want to be very clear that this point on this blue line is a random point that I selected. So this point is located at, just kidding, 3, 5. Now you could choose a different random point as long as it's on one of the lines. Then I'm going to use the opposite reciprocal slope to go down 1 over 2, down 1 over 2. So down 1 over 2, down 1 over 2. Down 1 over 2. Like that. And for some reason, I'm starting to hesitate because take a look at this. My goal right here is to have a 90-degree angle. So if I were to connect this, and I'm going to connect it, this is wrong, so please don't write this down. This is really wrong. If I'm going to connect it, and I really want to show you, and I'm happy I actually made this mistake. We get to learn from my mistakes. Let's see if I can make it unblurry. There you go. If we take a look at our previous examples, let's do this one. Notice that we need to have a 90-degree angle between our line and our intersection. Okay, so if I was to draw a 90-degree, this is not a 90-degree angle. You can see that. So I did something wrong. So let's go ahead and recount our slope. And I think I know what I did. I accidentally went to the left and not to the right. So I'm going to erase this and I'm going to try again. This is why I encourage you to, especially in this step, use pencil. So down 1 to the right 2. Down 1. See, this is what I did. Down 1 to the right 2. But now you can see that I'm kind of moving away from my line. That's okay, because once I have my pattern, I can go up 1 to the left, and we can have our intersection. Whew, I got worried for a moment. So now we're going to connect, and you can see the difference between what I had and what I have, in that I now can create 2 90-degree sections. Notice I did not connect my other points, so these other points can be removed. We don't want anything extra on our graph. And so now we want to identify point 2. Now I've already identified the original random point. This second point, point 2, is not random. This point I found using the perpendicular slope. So we're going to find using perpendicular slope. Now, step D is going to be finding the distance between the two intersecting points. So we're back to writing the distance. We're back to rearranging the kitchen. So that means you keep the house, you keep the square root. That part's not going to go away. So we have x2, x1, y2, y1. And we're going to label our points. Here's x1, y1, x2, y2. Y2 is, sorry, x2, almost messed up there. Can I save it? No. x2 is 1, x1 is 3, y2 is 6, y1 is 5. So you're going to type this into the calculator exactly how you see it. 1 minus 3 squared plus 6 minus 5 squared, and I get 5. Now again, if you can simplify, go ahead and simplify. 5 does not simplify. So this is your answer. Okay. And moving on to our last question. Exactly the same thing now, two different equations. Let's go ahead and start by graphing the first one. Oh, actually, before I start graphing the first one, I want to show you again the slope. Because we are dealing with two parallel lines, these slopes are going to be exactly the same for both. So I have a down negative. So we're going to go down 1 and to the right 3 for both. Both of them are the same. Let's see if I can make it a little clearer. There it is. All right. So the first one, I'm going to find a positive 2 on the y-axis. Here's a positive 2. I'm going to go down 1 over 3, 1, 2, 3, down 1, 1, 2, 3, down 1, 1, 2, 3, 1, 2, 3. And again, once you run out of space, you want to continue that pattern on the other side. Grab your rulers. For me, it's still my paper. And I'm going to try my best to... Oh, my line's a little bit off. That's okay. And now we're going to do the next one. And I'm going to find a negative 8. Negative 8 is down here. Again, down 1 to the right, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And then follow that pattern. And connect. Okay. So A, graph the two lines. Okay, I did that. Step number 2, identify the perpendicular slope. So again, perpendicular is opposite, reciprocal. Opposite means that if I see this negative, I'm going to have now a positive. And if I have 1, let me show you where I'm dragging my information from. There it is. And if I had 1 over 3, so now I have 3 over 1. Which means I'm now going to have a up 3 and to the right 1. Moving on to point number 1, remember point number 1 is your random point. So do you want orange or do you want blue? Orange, just because it's going to be closer to where my pen is at. And then I'm going to randomly say stop. So I said stop somewhere here. So we'll call this our point 1. Again, I really want to make sure that this is random on a given line. So I have 3 and -9. Now, point number 2 is not random. This is where I'm going to switch to pencil. As we saw in the previous example, I am human. I can make mistakes. So I'm going to switch to pencil. Now I'm going to use my opposite reciprocal slope, my perpendicular. So we're going to go up 3 to the right 1. 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. And you can see that point of intersection. Line that up. And again, this should create our 90-degree angles. Connect. Since we have 2 lines, 2 perpendiculars here, and we have our point number 2 at 6, 0. Almost done. Let's go ahead and label our points and find the distance. x1, y1, x2, y2. Writing out our distance formula. x2 minus x1, y2 minus y1. Fill in your information. x2 is 6, x1 is 3, y2 is 0, y1 is -9. Be careful with the double negatives here. Remember, before you touch your calculator, you're going to need to rewrite the square root. Then you can type this in. We have a 6 minus 3 squared plus open 0 minus -9 squared, and I get 90. Again, when you can simplify, you must simplify. So this one here, just to save time, simplifies to the square root of 9. Yes, you need the square root, and the square root of 10. Yes, you need the square root. And then when you simplify the square root of 9, that's when the square root can disappear. This is where it's just 3 square root of 10 for your answer. Okay. This is the end of our practice test. I need you to, again, remember, proofs are not included in this practice. They will be on the chapter test. So you need to pull out your chapter 10 proofs, and that's what we're going to be working on next. Second reminder, on this test, this is going to be your last chance for any sort of extra credit for the semester. Extra credit will be from chapter 5, 6, 8, and 9. Make sure that you are also studying your previous chapters for your last chance for extra credit. Enjoy the rest of your day. Goodbye.